Dear students, I want to explain for you chain drivers. We know that chain drivers is one of the elastic transmission mechanisms, similar to the belt drivers, especially for the timing belt drivers. Chain drivers consist of two sprockets and chains. So smallest sprocket usually worked as a driving sprocket and largest sprocket as a driven sprocket. When motion transmitted from the driving shaft to the driven shaft, velocity of the shafts decreases and torque on the shaft is increases. This is chain. Main parameters for the chain drivers is the pitch. This is distance between the two axes of the chains, or distance between the two adjacent trees of the sprockets, width of the chain, and center distance between the shafts. This is plan of the lecture. Let us explain the topic about these according to these plans. Chain drivers. Sketch of the chain drivers has been shown here. This is link of the chain. Chain consists of the rings, axis, and this one is smallest sprocket. This is largest sprocket or gear. Driving element is also maybe called as a pinion. Chain drivers use it for the transmission of the power between the center distance, which reach it to 8 meters, and sometimes may be reached to more than 8 meters. Chains use it for the transmission of the power at 25 meters per second, and there are chains which may be transmit up to 110 kilowatt power. Application of the chain drivers are found on the mainly agricultural machines, on the hoisting machines, for example, hoisting drum cranes, on the hoisting and conveying machines, and metal cutting tools. Main advantage of the chain drivers is that there are no slip, because velocity ratio is has a stable velocity ratios. Chains made from the metal before the loading capacity is very larger than transmission belt transmission mechanisms. Less space, the compression of the belt mechanisms. There are very high velocity ratios, up to 98%. There are no required tension on the chain because it gives less load on the shaft. It has ability to transmit motion to several shafts, only one chains, from one driving shaft to more than two driving shafts. It permits high speed ratio at 8 to 10 in one step. It can operate under adverse temperature and atmospheric conditions. Disadvantage of the chain drivers is that it is cost of the chain is relatively high because chain made from the metal and using complex manufacturing methods. The chain drivers needs to accurate mounting and careful maintenance, particularly lubrication and slant adjustment. Chain required lubrication of the friction pairs, but belt drivers not required in lubrications. The chain drivers has velocity fluctuations, especially when unitly stretched. Main parameters of the chain, we said that is pitch. This dimensions is pitch, denoted as P or T, from the center of one axis to the adjacent axis on the chain, or distance between the two teeth on the sprocket. And then pitch circle diameter is also main parameters for the chains. These pitch circle diameters, this is say that pitch circles of the pinions or gears. It is the width of the chain. This is horizontal distance between the plate of the chains. As the dynamic parameters, braking load is main parameters. Transmitted power also is main parameters. Velocity ratio, number of the teeth on the sprockets, and center to center distance is the main parameters. For the projecting of the chain drivers, as the input parameters may be given velocity ratio, transmitted power, and speed of the driving shaft. Pitch of the chain may be calculated from these figures. P is equal to AB, and AB from this triangle may be found as this forms. And theta, this is angle between the two axis and centers of the sprocket. We know that this centers, this angle is equal to 360 degrees divided by number of the teeth. T in this formulas, number of the teeth on the sprocket. And pitch circle diameters may be calculated from this figure as using these equations. Outside diameters denoted as D0. Length of the chains or number of the chain links denoted may be denoted L or K, number of the chain links. If given the pitch of the chain, length of the chain is equal to pitch product to number of the chain links, which number of the chain links may be calculated using these equations. In these equations, T1, number of the sprocket on the pinion or smaller sprockets, number of the teeth. T2, number of the teeth on the largest sprocket or the driving sprocket. X or A is center to center distance. P is pitch. We know that these equations also very similar to the belt equations. And after the calculating of the number of the K link, the value of the K must be approximated to the nearest even number. This is very important for the construction. In order to accommodate sag in the chain, the value of the center distance, which calculated from these equations, according to these equations, decreases by 2 or 5 millimeter, or approximately 2% of the center distance. Minimum center distance of the sprocket may be found from the adjustment of the sprocket. Minimum is equal to radius, say that diameters of the sprocket, some diameters of the sprocket divided by 2, or radius of the diameters plus to 30 millimeters, say that 30 millimeters minimum. Optimum center distance is equal to 30-50 pitch of the chain, 30-50 times of pitch of the chains, and maximum center distance may be reached to 80 times of the sprocket. Velocity ratio of the chain, may be calculated as the ratio of the velocities, angular velocities or rotation per minute of the shafts from number driving shaft to the driving shaft, or also may be calculated as the ratio of the number of the teeth, Z2 or T2 teeth divided by T1. Sprocket teeth and another sprocket teeth divided Z2 divided by Z1. Okay. Where is the pen? Okay. In this classification of the chain, chains may be classified depending on the field of applications. Power transmitting chains, we learn this type of chains. We will learn this type of chains, conveyor chains, and hoisting and hauling chains. This is construction of the chains. For example, this type of chains, oval length chains or square length chains, use it for the hoisting and hauling chains. For the load hoisting mechanisms, the crane mechanisms. For conveyor chains, this is very similar to the power transmitted chains. This is also push and roller chains at these forms, but this is used for the conveying of the loads, goods. And power transmission chains, this is divided depending on the construction block or push chains, and push and roller chains, silent chains. This is silent chains. This one is oval length chains, and this is plate chains. This is also push roller chains. This is also roller chains. Depending of the number of the roller, there are simplex chains, duplex chains, and triplex chains. For example, this is duplex chains, and this one is silent chains. Silent chains. This is triple chains. Hoisting and towing chains. These chains use it for the working of the cranes and hoisting machines. Construction of the chains may be at these forms. Conveyor chains. These chains are used for the elevating and conveying the material continuously. In the conveyors, elevators, and others. Power transmitting chains. This is used for the transmission of the power motion from one shaft to another shaft, changing of the kinematic parameters of the shafts. Construction of the chains may be block and roller chains, push and roller chains. For the this is external plate and this one internal plate. These plates joining each other using the axis of the chains, and on the axis mounted roller, sometimes on the roller also on the axis mounted bush, and sometimes on the bush or only the roller may be used for the in decreasing of the loss of their loss in the contact surface of the chains. Okay, bush roller chains generally use it for the power as if power transmission chains. On the section view, you can see that it is consist of the bush. Inside of the bush, there are axes of the chains and roller, and inner link or plate, inner plate of the chain, and outer link, external plate of the chains. This is a type of the roller chains. There are simplex chains, doublex chain, and triplex chains. And P is pitch of the chain, distance between the axes of the chains. D1 is diameters of the axis of the chains. B1 is main parameters, distance between the internal plates of the chains. And PT is chain pitch, and for the duplex chains, tangential pitch, and for the triplex chains also there are two tangential pitch. Silent chains. This chains is also known as inverted tooth chains because link of the chains is very similar to the two-teeth links, designed to eliminate the evil effect caused by stretching and produce noiseless running. But construction of the silent chains is more complexable because this type of chains seldom use it for the transmission of the power. Main parameters of the roller chains may be selected from the table. This is chain numbers according to the ISO standards. Main parameters is pitch of the chain, measured using the inch value. 25.4 is 1 inch chains. Roller diameter D1, width between the inner plates, transverse pitch, and breaking load, dynamic parameters for the chains. Depending of the pitch, maybe find another parameters of the chains. Force and factors of safety for the chains. Which force acted on the chains? Force acted on the side of the chain, F1 and F2. And tangential force, transmitted force, calculated using these equations, P divided by Y, V, velocity, tangential velocity, or 2T1. T1 in this formulas is torque on the driving shaft divided by D1. Okay, this force acting from the slacking of the chains, Ks is slack factor. Q, this is weight of the chains for the 1 meter chains. A is center distance, and G is 9.8. Okay. If C is centrifugal force, calculated at this forms, Q V square. V is tangential speed. And force acting on the tightening side of the chains, calculated at this forms, tangential force plus to force acting from the slacks and centrifugal force, and the force acting to the driving sides of the shaft, F2. In this equation, there are no tangential force. Force acting from the chain to the shafts, calculated using these equations, KB Ft plus 2F0. F0, force acting on the sides of the shafts. And safety factor may be calculated as braking force, this selected from the tables, divided by force acting to the driving side of the chains. Also, braking force may be calculated empirically using these equations, depending of the pitch of the chains. Ks, sliding factors, for the horizontal drivers is maybe 6, and for the vertical drivers or more than under 40 degrees to the horizontal, maybe take 1 to 1.5. Factor of safety for the different type of the push roller and silent chains may be found from these tables. And also permissible speed of a smaller sprocket, limited for the chains, depending type of the chains may be found limiting speed from these tables. Design of push and roller chains. For the designing, at first must be given the velocity ratios, transmitted power or torque on the driving shaft, and number of the smallest sprocket. We at first have to select the number of the chains, row, simplex chain or duplex chain or triplex chain. For the simplex chains, M is 1, for the duplex chain is 2. And sigma B or PB, this is bearing stress of the chains. This may be selected depending of the pitch and velocities on the driving shafts, or angular velocities of the driving shafts from the tables. Area of the projections of the pin joint may be calculated as these forms. This bearing stress also calculated as depending of the transmitted power force, tangential force, and area of the contact surface. And service factors, this is service factors taking into account some factors on the servicing. Permissible speed of the smallest sprocket may be found from these tables, and power transmitted by chains. Power transmitted by chains may be calculated depending on the braking load, velocities, safety factors, and service factors from these equations. In this equation, service factors taking into account the different type of loading conditions, center distance conditions, synthesis or position of the chain mechanisms according to the horizontal, tightening methods, lubrication methods, and working regimes. Design of the silent regime, it is not important for our lections, but in this figure, equations calculated the width of the chains main parameter as the main parameters. Lubrication of the chain is very important. There are different type of lubrication methods. At first, maybe periodical lubrication with hand using an oil can, or maybe using the oil stream lubrications at these forms, or lubrication with the oil at these forms, oil carters. Number of the smaller chains. For the number of the smaller chains for the sprocket, take it as at least, depending on the roller chains, number of the smallest sprocket, minimum Z1 minimum is 10, 7, but may be calculated at these forms for the roller chains and for the silent chains. In this equation, U is velocity ratios. Okay. This is a geometrical construction calculation of the chain, lean chain sprockets, dimensions, and pitch circle diameters of the sprocket calculated depending on the pitch, P divided by sine, P divided by Z. Z number of the sprockets, Z1 for the pinions, Z2 for the gears or driving chains. Outside diameters, input diameters, this is inside diameters, and this one is external diameters. This is varied to the addendum diameters of the gears, and another dimensions, width of the chains. This width depending on the construction of the chains, and top dimensions, half and length also calculated depending on the diameters of the shaft. This is drawing of the smaller sprocket, and another in this chain materials, materials may be select as steels, middle carbon steels were used for the chain materials. Materials for the sprocket also is steels, and if velocity is not very high, maybe use it cast irons. Sometimes plastic materials or composite materials, or also maybe use it for the sprocket, but this type of materials applicable for the low speeds and light loads. Link of the chains also made from the middle carbon steels. This is number of the steel, designation of the steels. And force acting of the chains has been shown on these presentations. Tangential force. Also tangential force may be found as the similar to the belt mechanisms. F1 divided by F2. Centrifugal force and sagging force. Kinematic of the chains. On the kinematics, velocity of the chains calculated, and velocity ratio of the chains. Main performance criteria of the chains is the wear lost, or wear designed calculated according to the wear resistance of the chains, because from the criteria of the wear resistance calculated middle pressure or bearing pressure on the chain links. This is chain links, and this is result of the bearing pressure. If bearing pressure, calculated bearing pressure, is not less than allowable pressure taken from the table, we must increase the chain link, chain pitch, or select another chains. Okay. In this presentation, given the different type of chains, this is simplex chains, and this one is silent chains, or maybe triplex chain. This is a triplex chains, and this is chain links. In this sketch, you can find any element of the chain. This is Walgic axis of the chains and push of the chains, or inner links and outer links. Classification of the chain according to its applications. Also in this figure, this is simplex chains, triplex chains, and duplex chains and triplex chains. This one is silent chains. Application of the chains. Okay. Thank you very much for attention, dear students.